Good day to you. This is out of Galactic on the 9th day of January 2024 with our probe into a new form of space. Of course, space is space. That's physical space. But the way we formulate space depends on our construction in our minds. The attempt has been, in my little laboratory here, to find a different construction of space that matches physics. In the 20th century, it was discovered that the universe is spherical at all scales. There are no exceptions to this rule. The universe itself is definitely spherical. One reason we know that is due to a perception that the universe is homogeneous in all directions. Sometimes the word is used isotropic or isotropic, I understand is a better pronunciation if one is a pedant, and isomorphic. All these mean is it looks the same in all directions. Well, that would be a spherical direction. The only reason there's any doubt about that is that without an edge, which that implies not a center, it's hard to say that it's spherical. However, we have two new proofs as of the 20th century. Gravity is spherical. That has been known for a long time, certainly since the time of Kepler. And it really just depends on how well formulated the notion of gravity has been. Einstein did refine the notion of gravity according to his space-time construction. That is a grid. So that's not a match. So that can't be the right answer. There is more than one right answer, though, because we do know that linear space undergoes a transformation, again, in the human mind, to spherical construction. The convolutions of doing things that way have resulted in the sine-cosine relationship, which is based on essentially a transcendental function, which means that it's irrational. Now, we wish to begin today by pointing out that geometry will not admit irrational numbers. Essentially, that means that the linear system requires integration. In order that we might have a spherical geometry at an axiomatic basis, which would be both numeric and geometric. That has been elusive, but it appears that I have discovered the correct transformation, which gives us the ability to begin in spherical space. That is, we don't have to construct it. Does the line require construction? No, it just exists. So does the sphere. Well, the sphere then should be susceptible to a number system. Now that we have that, it turns out we have the perfect number system for the formulation of spacetime. Beginning at that juncture, which is very recent, we have found that there are two edges to spherical space, one being the infinitesimal, which is at the center of the space. The question now is, can we match that to physics? In order to match the grid to physics for gravity, Einstein was forced to bend the lines, essentially. This is done mathematically, of course, because geometrically the lines remain lines. What we've done is to integrate the concept of line into a closed line. This is the line that the universe uses. It may sound strange to refer to the sphere as a line. The better analogy would be that the sphere corresponds to a point. Certainly, if one begins at a point and goes out spherically, one obtains spherical shells. The trouble with that is the center. What I found out from pondering that enigma is that that point may not exist, and therefore the concept of a point might be limited to the concept of a line. Now visually, that would stymie us, and it has, because the center of a spherical space would by definition be a point. But that's a relative term. It's a point in comparison with everything else, which would then be spheres if one is beginning with a spherical construction. But is there such a thing as an infinitesimal sphere? Well, that has been discovered in the 20th century, and it's called a proton. The proton has an exact radius. That is difficult to prove, however. What can be proved is that the proton, with respect to electrons, creates spherical shells. The explanation for that has never been discovered. The current formulation, insofar as there's any formulation at all, has to do, of course, with electrodynamics, where the proton is considered to have a charge, and the electron has the opposite charge. The problem with that is it does not match the geometry. Plus and minus are strictly linear concepts. Now, in the formulation of electrodynamics, the concept of a plus charge and a negative charge in terms of pressure has been established. But when it's transferred to the atom, it no longer matches. Einstein found out why, but essentially, Einstein was dealing with gravity, not with electrodynamics. And ever since, there's been a search for a unification model which would unite gravity with electrodynamics. It's remarkable to me that Einstein actually discovered part of the answer without fully realizing that he had done so, and nobody has realized it since. In order to construct his four-dimensional space-time, he was, of course, forced to rely on our notion of cubic space, something which appears to be inescapable. And of course, our spheric construction tends to escape that. But what that has done is forced Einstein into a construction that's geometrically correct. It's certainly geometrically correct to the threshold that it improves on Newtonian gravity so greatly that we now have the capacity for astrogation, that is, navigation through the solar system. It can be shown that that is not possible with Newtonian gravity, because in computing the various effects of gravity throughout the solar system, which would be necessary for precision flight, certainly to get the James Webb Telescope to Lagrangian point number 2, requires an incredible amount of precision. But that is possible, and only possible, using a notion of gravity that takes into consideration the time differential. And so Einstein concentrated on this notion of simultaneity and non-simultaneity to reason out some kind of algebraic and ultimately geometric relationship between space and time, resulting in an orthogonal relationship between cubic space and time considered to be an axis. It would be an oriented axis. The result of his formula, the Einstein field equation, is so incredibly accurate that any amount of precision can then be obtained for the mutual influences of gravitational forces throughout the solar system so as to enable precision flight. And of course, this is done with calculus. It is calculus that allows the narrowing of the gap, essentially between numeric approximations, so that the gap between the numbers is limited down to what's called an infinitesimal, which cannot be ultimately eliminated, but it can be reduced to any precision, and that's sufficient for building machines for flight. In the spheric construction, this would begin by defining gravity on a single force, which is a force line coming in from all directions to the gravitational center. This is equivalent to Einstein's formulation. He did regard gravitation to be the result of a mass body that has a center of gravity. Because these bodies at macro scale are spherical, that's fair to say, this is a spherical field. A field is a pressure that's exuded in space. It's difficult to find the right word. And in fact, the term force is eschewed by a certain point of view. It is said that gravity is not a force. This would depend on one's definition of force. In a recent video release by Sabine Hossenfelder, she said just a few too many times, she repeated over and over throughout her presentation, that gravity is not a force. It's okay to say that once or twice or a few times, but she kept repeating it, and that indicates something to me. Of course, I'm already biased because I know that it is a force, but that raises a question: why does Sabine keep saying that it's not a force? It is because it's passive. You could say it another way. It doesn't do anything by itself. Really, this means that a force is generally conceived to involve a motion. But gravity does not manifest a motion. What it does is that it effects a field that induces a change in motion. So that gravity, to be considered a force, as I do consider it, would require an extension of the concept of force to something that can bend space. Now, it's remarkable in this context that Einstein discovered that you can actually conceive of space as being bent. And in fact, that is what Sabine kept emphasizing. Rather oxymoronically, but that's not fair. I gave her words a lot of thought because this is part of the paradox. That for gravity to be considered a force, it has to do something. And the only way we can say what it does is by its effect on objects around it. Now that would even include the atoms in a body of the macroscale size of a planet or star. The sphericity of cosmic bodies, such as planets and stars, is induced by the centripetal force of the gravitational field, which has an effect even on the tiny objects, the atoms, really the protons that are bending the space. But this turns space into a fabric. If that's the right point of view, which it is generally conceded that it is, I would say it's a convenient point of view, which I see no better point of view than that space is being bent. Well, that bending would be from a non-bent state. So gravity induces an effect in space. We can say this for certain because of the existence of Lagrangian points. And probably the best example of that is if you have a two-body system, you can visualize that the force of gravity comes out of one body and overlaps with the other. Well, where those overlap, it's pulling in opposite directions. Not opposite, but in generally opposite directions. And this induces the 5 Lagrangian points, which are balance points of gravity where there essentially is no gravitational tug. Or you could equally say, or equivalently say, that they've canceled, somewhat like interference. But however you say it, the James Webb Telescope is parked at what amounts to a parking slot where very, very little thrust is needed to maintain an orbit around an imaginary point. It's really a geometric point. All of which is to say that gravity may indeed be considered to be a force, but there is a problem with that because of the Newtonian principle of for every action, and a force is an action, there has to be a balancing action, an equal and opposite reaction. That was confirmed to a new threshold, which was considered monumental enough to earn a Nobel Prize, to Emmy Noether, who knew Einstein, and Einstein very much liked Emmy Noether. And Emmy formulated her force balance symmetry proposition, which has become accepted. I compare it to the Newtonian principle of force balance, and we have a third voice to add in there on the topic of force balance, which is that of Ruđer Josip Bošković. We're going to capitalize on the work of all three of these brilliant scientists in order to discover what is the force that balances gravity. Now, we've already discussed, and I'm just going to summarize here, that the force that we're talking about is centripetal force. The proton exhibits centripetal force with respect to an electron, one or more protons and electrons. The periodic table describes the several relationships that can exist in an atom to construct the elements and their isotopes. The presence of the neutron has to be taken into account. It is considered to be a proton without a charge. In other words, the neutron does not affect the electron with a centripetal force action. We do need to take all of these things into account in order to get a unified field theory or a unified theory of some kind. This is a field being described as a force that's exerted through space. But more needs to be said there. Rather than delving into the details and minutiae of a field, which is a geometric concept of tremendous value, we do observe that the proton exerts what appears to be a centripetal force, but at the atomic scale, we only know of that by the action of the electron. From that, we could hypothetically state that the electron is an antiparticle with respect to the proton. In terms of charge, they are of opposite valence. However, this is now referring to a force. The energy that is being referred to in charge relationship is usually discussed in terms of pressure and flow of electricity and the associated magnetic field. Magnetism is obviously a form of centripetal force, whereas electricity, its counterpart, wherefrom we get the term electromagnetism, the electricity is a motion, really a pressure, and you really have to say both. But it is a pressure or motion induced by a force, and magnetism must therefore be considered a force. And so all three forms of centripetal force that we know of in physics, the protonic centripetal force, the gravitational centripetal force, and the rather hybrid, I would have to say, magnetic force, are all pulling in. The opposite direction in spherical space is going out, a pressure outward. That is much more easily identified because there's only one candidate for that force, and that is the propagation of light in free space. This is commonly referred to as a particle manifestation. Newton thought so, but even Newton knew of Huygens' work. I shouldn't say even Newton knew, but Newton knew of Huygens' work, and even Newton knew that the corpuscular, which is a particle theory of light, was not fully explanatory, but he preferred it. I think that's fair to say. In any event, it was Albert Einstein, once again, who produced an explanation for the photoelectric effect, which is essentially to prove the particle nature of light. And he did use the word quantum, a quantum of light. I had said in an earlier presentation that it was Einstein who invented the word quantum, but I should not have said so. Really, Planck did. He did use the word quantum. And Planck didn't really like it, though. And it really was Einstein who popularized the term. And it was because of Einstein's use of the word quantum that it became popular. I think, again, that that is fair to say, but that's a matter of historical judgment. In any event, Planck had discerned and proved against his will that the transfer of energy is apparently not continuous. He was able to show that the only way to conceive of energy transfer at the smallest level is a jump. There is a jump. So it's non-continuous, it's discontinuous, and this forces the word quantum, a packet of energy. A photon is considered to be an energy unit, an energy packet, a quantum of energy. So is an electron. And here we wish to begin to explore the nature of the photon, which is really what I've been after for these 2 years, which is a quantum phenomenon, quite obviously, because of its packet nature, that it does appear to behave as a thing and not a continuous thing. This is exactly the difference between a wave and a particle. Energy is known to manifest as a wave, and therefore both the electron and the photon require some explanation for why they're coherent, that is, that they form quanta. The electron is considered to be a particle. Let's begin there because of the relationship between the electron and the proton is geometrically of huge significance in the spherical construction that I've formulated, as well as its traditional interpretation in grid space. When one does construct spherical geometry for real space, physical space, one must take into account the outer infinity, and by doing so, we've proved that there must be a reciprocal to infinity at the center of the system to balance it geometrically and numerically. If, as we do wish, there is to be a number system, there must be a reciprocal infinity at the center of the system. This would correspond to the proton if we can prove it. But what would that mean how would we relate that to what we already know of physics? This is a change in the perception of the space that comprises the proton. We've been unable to penetrate the proton except with one mathematical probe. That is, a deduction was made by Gelman showing that there is a mechanism associated with the proton. But the proton is essentially known by its field effect, which affects the electrons by apparently bending the space around it. Now that needs to be translated now into force terms. It was Ruđer Josef Bošković who pointed out that the construction of such an infinitesimal would involve the infinitesimal being impenetrable, which is our definition of the center of spherical space. The 1 over infinity dimension would be the interior of the smallest concentric sphere in the system, inside of which is anti-space. If we accept that for the construction, the geometrical visualization of the proton, we must then somehow address the anti-space. I was finally able to realize, really over the past 6 months, that this implies another kind of force, or another aspect of the same force that we're talking about. In order to have a shell, that is a surface, at this scale, we're talking about a 1 femtometer range. That's the smallest practical unit in physics. It's the subatomic scale unit. Atoms are measured in femtometers. And a 1 proton, 1 electron system has a proton that has a radius of approximately, now here I must pause. The force curve that Bošković drew for the ultimate proximity of atomic particles, he was thinking of the Greek particle, which is simply the smallest unit. This would be the quantum. But these days we must say the quantum of space. It's not a temporal phenomenon. It's nothing to do with motion. It's purely static. So the particle that he drew was a manifestation of force. And the force exuded by this indestructible, really impenetrable is the word that he used, what we would call the proton, is an impenetrable center of a force system where the other particle, he simply considered it to be another particle. He did not know of the difference between the electron and the proton. And therefore, the force curve that he drew was for two protons. However, he did identify the relationship between the electron and the proton as the electron being pulled in by the other particle. That is, they have a mutually attractive force. This would describe the proton and electron, with the exception that we consider the electron to be drawn toward the proton. In his system, they're mutually balancing forces because the other particle would have some kind of impenetrability and force field. Considering those to be two protons, that I should say two, in the ancient term atoms, two particles of no charge. He was not aware of any charge relationship. If one particle is heading towards the other one, they eventually will contact. And his objective was to describe the contact. At the time, he followed right on the heels of Leibniz and Newton, but it was Leibniz who dealt most particularly, pardon the pun, with what happens when two particles collide or contact. Can they contact? Do they interpenetrate? Are they continuous and they simply merge? Or merge to a new degree? It was unclear what would occur between two atomic particles. Bošković, having pondered all of this, and according to what he said, he pondered it for a long time and he developed it for a long time, but his initial insight was that there must be a continuity in force. What we would say is that force is continuous, but then energy would be continuous. Now, we do know that the electron is a wave. The strange thing about this wave is that it's a standing wave. So it's very difficult to figure out what holds the electron together. If it's a wave, why does it bind? The reason why this question would arise is that the photon behaves as if it were a detached portion of the electron, but is no longer bound. So the only difference between an electron and a photon in this respect is that the photon, being unbound, goes into free fall. And this free fall, which we measure as light speed, is centrifugal force. And this would be the balancing force. But what causes this force? What causes a photon to travel outward as a sphere? Under the traditional force mechanics that we're aware of in macrospace, it would have to have an impetal force to create velocity. And the photon has a velocity, but it's a very strange velocity. It is the most precisely measured anything in the universe. Nothing is more precisely determined in physics than the speed of light, which is a velocity, which is a two-component number. It's a relationship between distance and time. It's essentially the distance covered in a certain amount of time, which is approximately 300,000 kilometers per second. That is a two-component number in the fraction relationship, which is a proportion. So if we can call the force the impetal force of velocity, what would that be? What would be the impetal force that causes the photon, what we call light, just light propagating through space, propagates as a spherical wavefront? Why does it travel? Normally that would require an impetal force. What is this force? Well, it would have to be centrifugal force. But that raises a paradox, but happily I'm able to say we now have a match on two paradoxes that are absolutely balanced. There's a skew relationship though, so let me elaborate. When we think of gravity, and you can think of the atom as a small gravitational system, just accept that for the moment, there's a centripetal force drawing in towards the proton. In gravity, it's the combined force of all the protons. That is the definition of mass, and it is mass that is responsible for gravity. Obviously an integral force. It's the integration of all the overlapping centripetal forces, centripetal force fields of the protons. So that induces a gravitational field around a macroscale object, a centripetal force manifestation from protonic centripetal force. The phenomenon of magnetism can be explained this way, but that is rather a hybrid. It's between the two. It has electronic, I should say electromagnetic characteristics, but it also has this strange effect. You can see it with two magnets. They induce a field, which then induces the same effect as gravity, essentially. It's a centripetal force. So that's one of the two directions in spherical space, is going from the outside to the in. Well, in the case of a proton, you'd have to say that's it's infinitesimally localized space. But we see that that can merge to form macroscale centripetal force, a large-scale centripetal field. Light appears in many ways, or in one obvious way, to be the opposite. It's the manifestation of a centrifugal field. What is this field? Light travels through space, so there is a relationship clearly between light and space, that space appears to be the medium of light. However, that medium was never discovered. It was given the name ether. And whatever can be said about that idea, it's not a substance. It's not a medium in the sense of air or anything else. So light has this property of passing through transparent materials, such as, well, glass and water, but it does slow down when it does so. So that's an interesting aspect of light, which is the study of optics, a most fascinating field, and if I had 1,000 years to study something, I would very likely choose optics. So the question then arises, if the proton manifests centripetal force in space, then what can we say about the manifestation of light propagation at light speed through space, which is the maximum speed of light, beyond which nothing can go, and which is also an interesting thing to say. So it is some kind of limit. What is it the limit of? But really our question is, what causes it? What causes light to behave this way, that it simply goes out? It's going, where is it going when it goes out? Well, it's going out to the edge of space. It's heading for infinity. Whatever light there is in the universe is propagating in all directions, and the paths crisscross, apparently without interference, or we would not be able to see the distant stars and galaxies, certainly not the galaxies, because the light is crisscrossing paths. Well, it does so without interference, which is an interesting thing. But we still haven't answered the question. What is the cause of its velocity? Of any velocity. It doesn't have to be that velocity. So one question is, why is it specifically that velocity? But really, why does it have any velocity at all? That would have to be due to a force. And therefore it is proper to say that, first of all, you have to know what induces light. It's the excess of energy in an electron. And in the case of atomic structure, we have to say it differently because the electron has two forms. We conceive of the electron as a particle since it can be fired from a gun, re-raising the question of what holds the electron together as it's fired as a particle through space. It's not dissipating as it goes. Although, that's also difficult to say, but it does behave as a bona fide unit. When you fire it, it doesn't dissipate. It goes in a trajectory, a straight line trajectory. So it is a particle, but what holds it together? Well, something holds it together, but whatever holds it together can be violated. In the excess of energy that constitutes an electron quantum, I believe I can put it that way. In this case, it's a shell. The electron is involved in a shell system in an atom. And when a photon, again conceiving light as a particle, which is a strange thing to say since it's not propagating through space as a particle, but the paradox is when it arrives at its transition to its absorption point or moment, it ceases to be a particle and becomes part of the electronic system, in this case of the atomic shell. And then there's an excess of energy in the atom, an excess of electronic energy. It has too much energy to maintain the atomic balance, and we know what happens then. It releases another photon. There can be intermediary states because electrons can change state by changing shell. But when the excess is sufficient, it releases a photon. It can be called a photon at the point of release due to the nature of quantization. So a quantum of energy is absorbed, and then when there is an imbalance sufficient in the system, it releases a quantum of photonic energy, which then immediately travels outward at a fixed rate. The question then being, why? Well, the opposite of centripetal force is centrifugal force. And we do know of this effect from, for instance, the playground merry-go-round. All children learn about centrifugal force by holding on to the bar as some other kid spins it faster and faster, attempting to turn the child into a photon, who will then travel out, although not on a spherical trajectory, but essentially a straight line out. And then you learn how to tumble without breaking an arm. So that's centrifugal force. It's not pulling in, it's throwing out. And that is a very good description of what happens with a photon. It's thrown out. So what is the force then? It's the force that's inherent in the electron. So it's now proper to say that the electron is a manifestation of centrifugal force to the same proportion that the proton is a manifestation of centripetal force. And then these two forces can be related on the equation of symmetry, such that the universe is a balance of centripetal and centrifugal force. And this is the essence of the discovery made by Ruđer Josif Bošković, that the particle system that he devised is constructed on a series of curves, and the curves represent the relationship between attractive force and repulsive force, with a median line of no force. And this describes very precisely the shell system of an atom, that it's based on the balance between two forces. One is repulsive and the other attractive. The attractive force is centripetal and the repulsive force is centrifugal, in a series of shells. In association with each one of these shells is a balance between the centrifugal and centripetal field forces, which oscillate, and that produces the shell system of the atom. A remarkable insight, considering none of the particles involved had been discovered yet. What we wish to do now is integrate all of this incredible understanding that we have, not quite synthesized, but what I've discovered is the only proper way to synthesize this knowledge in the force balance system in the universe, which we consider to be gravity and light. These are the two forces. Although it can be better said, and we will better say it, but just summing it that way for now, the phenomenon of light manifests one force, and the phenomenon of gravity manifests the other force. How can we write an equation to balance them? That would be the ultimate unification theory. That's what we want to do. So, we have our spherical representational system, a new geometry, which captures the nature of the proton as this is without the concept of force. There is no force in this geometric system for the sphere. It's a static geometry, just the same as our regular straight line geometry. There is no motion involved or implied. Implied, though, in the spherical system there is something implied, but we haven't gotten to it yet, and I wish to broach that now so we can close this off at under an hour. Consider, then, the spherical space that we've constructed has an infinitesimal sphere at its center with anti-space in the interior. This would be the proton. Where does the electron fit? It doesn't yet. But here is what it would be if indeed the system we invented, this geometry, is strictly referring to space. We can construct another sphere that has the property of time. And this would have the same geometry, but with inverse spherical valence. In order for that to become a dynamic system, in order to relate two forces at least one of which involves motion, but really both of them involve motion in different forms. Centripetal force does not manifest motion, but it induces motion. Centrifugal force is motion itself. It is motion. In spherical space, spherical motion is out. There is no spherical motion in. However, there's a curvature which induces a change in motion due to a field force. So we're on the right track. We can use the same geometry that we've already composed to have the same inner surface. But instead of there being an imaginary interior, we could say that there's an imaginary exterior. This is the beginning of an inductive probe into the relationship between the two balancing forces of the universe to attain a unified field solution, no longer a theory. And that's enough for now. In the next lecture, we'll continue to explore this, but I wish to point out something, that in the spherical space that we first constructed, which simply defines space, everything is positive. Space is positive. The interior, however, would have to be considered negative. It is imaginary. What if it were reversed, and the interior were positive, and the exterior were negative? We would then have a framework for discussing force. The only two forces in spherical space would then have opposite valence. If you overlap those two, it's hyperspheric. And that's where we're going to begin in the next lecture. Thank you for tuning in. Don't forget to look up when the clouds part at night. Get out and look at the stars. It's the best time you'll ever spend on Earth. This is Out of Galactic. We'll be right back with you.